Hey guys, today we are talking about domain and range again. It's 1.4 real world examples or problems, whichever one you put, problems of domain and range. Okay, the notes today are going to be pretty quick. I'm just going to give you one example. And what you're going to be doing in class is I'm going to give you a worksheet, and there's about 8, off the top of my head, I think there's 8 questions and that you're going to have to work with your table group on finding the domain and range for real world problems. So let me explain this this example that I'm going to work out with you guys, and then you'll see what I'm talking about. Okay? Imagine those lines are straight. But what I want you to think of is that the rectangle I just drew is a piece of cardboard that measures 24 inches long by 18 inches wide. Okay? We are going to form a box by cutting congruent squares out of each of the corners of the cardboard and folding up the flaps. So basically, we're cutting out flaps like so. Now, I want you to imagine that these were, first off, congruent, even though they don't look like they are. But we don't know how long it is. So we're going to label it X, okay? If this side length is X, therefore that side length is X, and that side length is X. Do y'all see that? And same is true for all 4 congruent squares, okay? So now our picture, now this is going to be a rough drawing, but I want you to imagine we're going to have, that's the front piece, the side piece. I'm trying to make it as best as I can. So this is basically what it looks like folded. I'm pretty impressed with my drawing, not gonna lie. Okay, let me erase that as well. Now, we can figure out what these lengths are even though that we don't know what X is. All we know is that our new side length, so this length is 24, but remember we took out X values. So now the length of this is going to be 24 minus 2x. So my length in green is 24 minus 2x. Hopefully you can see where the 2x comes from because we cut it out. This piece, those pieces are now gone, so we cut those out. Okay. Same is true for 18, the width. It's 18 minus 2x because we cut that out. So let me draw that piece there. So 18 minus 2x. Okay? So that's my length, my width, and then our height is actually pretty simple. Because if we're folding it up, what must our height be? If you said x, then you are correct. So that is our h. Okay? Now the whole point of this is I'm going to ask you, what is the volume of the box given? Well, you should know that volume equals your length times your width times your height. So in this case, our length is 24 minus 2x times our height, or times our width, 18 minus 2x, times our height, which is x. Now, if we were to graph this on our calculator, we know that this would turn out to be a transformation of our cubic parent function. Okay, so we know it would look something like our parent function, which is roughly like that. Okay, and you would tell me that the domain is all real numbers and the range is all real numbers. But according to this picture, it's not true, because let's just say I'm going to pick out a random number. Let's just say I picked x equals a negative number. Okay, that's implying if we have a negative x length, okay, if we were to plug in x for these values, we would get an x, a negative dimension. Well, can you have a negative height in real world? No, absolutely not. You can't. So what we're going to do to figure out our domain, okay, so we know x cannot be a negative number, and if x was 0, you'd plug in 0 for x for all of it, and you'd get a volume of 0. Well, you can't have a 0 height, so x cannot be 0 either. So we know that x must be, I'm going to write it like this, x must be greater than 0, cannot be equal to, because again, if you plug in 0 for x, you can't have a 0 height, so therefore you can't have that. Now, there is, there's going to be a restriction on this side of the equation as well, because I'm going to pull out a number. Let's just say if we plugged in 10 for x. If we plugged in 10 for x, we'd get 24 minus 20. You'd get a length of 4, which is okay. And then you do 18 minus 2. Oops, we said that was 10. So 18 minus 20, you get negative 2, which is not okay either. You can't have a negative length. So 10 wouldn't work. So we have to find out what our highest value x can be. In order to do that, you have to take this side length right here, and we're going to set it equal to 0. So you have 18 minus 2x, set that equal to 0. Subtract by 18 on both sides, you get negative 2x equals negative 18. So you get x equals 9. So that's the greatest value x could be. Because if you, that's the restriction, I shouldn't say the greatest value, because if we plug in 9 for x, you'd get 0, and you can't have a 0 width for this problem. Okay, so x can be in this problem between 0 and 9. Okay, so you'd either write it like that, or you'd have parentheses 0, comma 9. So you can write it either way. Both of those are equal. Okay. When you use models to model real-world problems, there's going to be restrictions, and that's what we just talked about. Okay, and the restrictions are just arise out of purely algebraic issues, and that's why we set one of the lengths equal to 0 to figure out what the highest value our x can be. Each problem has its own set of issues, and you're just going to have to work it through and talk it out tomorrow, and again, I'll be coming around and helping you guys. Something else you have to keep in mind, if your independent variable is people or objects, you cannot use fractions, because you can't have half a person, or you can't have half a book, and you can't have negative numbers, because again, you can't have negative people. Okay, so that's something else to keep in mind. So it's one of those things that you're just going to have to work it out and talk it through and kind of use common sense to think through the problems. Okay, the range is a little bit trickier. So in like this problem, I would let you use your calculator to find out what the range is between the domain. So from 0 to 9, I would let you use your calculator for that. But again, here's an example of what you're going to have to do tomorrow. Hopefully I did a pretty good job explaining how you solve these problems through. Okay, and actually we're pretty much done with the notes. And come see me if you have any questions over the notes or the homework or the classwork from earlier today. And I hope y'all have a good night. Thanks.